Ever wondered how AI models learn so efficiently? Dive into the Atom Optimizer, a game changer in deep learning that combines speed and adaptability to train networks faster and smarter. Before Atom, optimizers had major flaws: slow convergence and tricky tuning. Let's explore the building blocks that made Atom possible. Imagine trying to find the lowest point in a valley with blindfolds on. That's basic gradient descent. It's simple, but often gets stuck or wobbles too much. Why use the whole dataset when a sample can speed things up? SGD adds randomness that helps dodge pitfalls, but it's a bumpy ride. Think of momentum as a snowball effect. Once you start rolling downhill, you build speed and smooth out the bumps for faster progress. What if each parameter had its own learning pace? Adaptive methods tailor updates, but they sometimes slow to a crawl. Enter Atom to fix that. Atom isn't magic. It's built on clever math like smoothing gradients and fixing initial biases. Ready to see how it all fits together? Why trust only the latest data? Exponential moving averages give recent gradients more say, making Atom responsive yet stable. Starting from zero can skew results. Bias correction tweaks the numbers so Atom hits the ground running without false starts. Gradients have highs and lows. The second moment tracks their intensity to scale updates perfectly, avoiding wild swings. Atom blends the best of momentum and adaptability into one sleek algorithm. Let's break down how it works step by step. Why choose between speed and precision? Atom does both, using momentum to glide and adaptivity to fine-tune every parameter's journey. Step into Atom's engine room. It grabs gradients, smooths them out, fixes biases, and updates weights, all in a tight, efficient loop. This is Atom's memory of past gradients. It builds momentum in consistent directions, cutting through noise like a pro. Big gradients mean big changes? Not with the second moment. It dials down the learning rate for volatile parameters, keeping things steady. Ever had a slow start because of bad initial guesses? Bias correction fixes that, so Atom doesn't waste a single iteration. Here's the payoff. Atom uses its smoothed, corrected data to nudge each parameter just right, speeding toward the optimum. Atom isn't just fast, it's smart. It adapts on the fly, smooths out bumps, and works reliably out of the box. What's not to love? One size doesn't fit all in deep learning. Atom tailors learning rates so every parameter learns at its own perfect pace. Oscillations can derail training. Momentum smoothing acts like shock absorbers, keeping the descent smooth and swift. Without bias correction, Atom would stumble out of the gate. This tweak makes sure it starts strong and stays strong. Tired of endless hyperparameter searches? Atom's defaults work like a charm, saving time and hassle for practitioners. Proof is in the pudding. Atom aced tests on real datasets, outpacing rivals and proving its worth in diverse scenarios. Even on simple tasks, Atom shines. It learned quicker and cheaper, leaving other optimizers in the dust on MNIST. Scaling up to neural networks, Atom didn't just keep up, it led the pack, thanks to that clever bias correction boost. Complex images, no problem. Atom trained CNNs faster and better on CIFAR10, proving it handles real-world vision tasks with ease. Gradients can be all over the place early on. Atom's second moment tames the chaos, ensuring steady progress from start to finish. Skip bias correction, and Atom slows down. This isn't just theory, it's a proven must-have for peak performance. Struggle with picking the right learning rate? Atom forgives your guesses, delivering solid results even with suboptimal settings. Ready to use Atom in your projects? Here's the lowdown on making it work: when to deploy it, how to tweak it, and what to watch out for. Atom is your go-to for complex models and quick results, but for some tasks, old-school SGD might edge it out. Choose wisely. Stick to Atom's defaults for most cases. If training drags, bump the learning rate. If it blows up, dial it back. Simple, right? Watch out for these traps. Don't skip learning rate checks. Use Atom where it fits and compare real training time, not just steps. Atom's tough, but a quick learning rate sweep can unlock extra speed. Why leave performance on the table? Atom isn't a one-size-fits-all. In some domains, SGD's simplicity leads to sharper models. Know your problem. Counting iterations can mislead. Focus on real training time to see which optimizer truly saves you hours. Supercharge Atom by teaming it with modern tricks. Batch Norm for stability, Warm Up for smooth starts, and Atom W for better regularization. Batch Norm and Atom are a dream team. One handles data shifts, the other fine-tunes learning, making networks train like champions. Start slow to finish fast. Warm Up eases Atom into training, preventing early stumbles and boosting overall efficiency. Exploding gradients can wreck training. Clipping reins them in, so Atom stays on course without any fireworks. Weight decay in Atom was messy. Atom W cleans it up by separating decay from gradients, leading to better generalization. Atom didn't just optimize networks, it optimized research itself, sparking a wave of variance that pushed the boundaries even further. Thanks to Atom, you don't need a PhD to train AI. It works great out of the box, empowering more innovators to build amazing models. Atom set a new benchmark. Researchers now test ideas faster. Knowing Atom gives a solid starting point for any deep learning challenge. Atom's success bred innovation. Variants like Atom W in RAtom tackle its weak spots, ensuring the legacy keeps evolving. Let's wrap it up. Atom combines momentum, adaptability, and bias correction to deliver speed and reliability, though it's not perfect for every task. Remember, Atom's power comes from 3 pillars. Momentum glides, adaptation fine-tunes, and bias correction kicks off strong. Don't overlook bias correction. It's the secret sauce that makes Atom hit the ground running from iteration 1. Atom's robustness means you can focus on your model, not fiddly settings. It just works, time after time. Atom isn't infallible. For certain tasks, simpler methods shine, and researchers are still unraveling why it excels in practice. Atom sparked a revolution in optimization, paving the way for even smarter algorithms that build on its groundbreaking ideas.